Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Pointing Parody by Some Guy 209. And here are the rules. Chaos construction rules. Divide the grid into regions, each consisting of orthogonally connected cells, and fill each row, column, and region with the digits 1 to 9 once each. Okay, so instead of the normal 3x3 boxes, we actually have to develop regions. And each row, each column, and each region must have the digits 1 to 9 once each. So for every row, for every column, and for every region, which is orthogonally connected, which means that the cells share an edge. So this would be a valid orthogonal region. I think that's one too many. 1, 2, 3, 4, 5, 6. Oh no, that's exactly how many. That's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This would have to contain 1 through 9 if this was a valid region. And we have a 9 by 9 grid, so basically all the cells are filled. Now, it doesn't have to be something like this, but an invalid region would be like something like this, because these are not orthogonally connected. This one's diagonally connected, but it's not connected orthogonally with any other cell in the region, therefore it's not valid. So that's chaos construction. Other counting arrows. The head of an arrow is the sum, so this is the head of the arrow, is the sum of all cells in the indicated direction that are in a different region. So they must be in a different region to count toward this sum. Example, if an arrow in row 1, column 1 was pointing down, so say there was some like arrow pointing down here. Say there was an arrow pointing down. Then, and it was in a region that spanned row column 1 to row column 6. So say it was in this region. Then row 1, column 1 would be in the sum of row 1, column 7 to row 1, column 9. So it's counting numbers that are not in its region. So basically, just remember that. So an example, like, so say this had, I don't know, was connected to like this, right? It would count every other thing on the diagonal except for this cell, because it counts all the cells that are not in its region. So that leads to some interesting interactions. Anyways, those are all the rules. Interesting. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. I'm not really sure where to approach this. Maybe long versions. Might be the best because you're very limited on what you can have there, right? But even that's not that limited. So this one could be something like this, right? Or it could be like 1 1 1 1 1 1. What are some interesting aspects? So this could be all three of these, could be two of them, could be one of them. This could be all five, technically. This could be two of them or one of them. Okay, so these have to be different regions. That's the only thing we know right now. So this has to be a different region from this, but we don't know. And they're the same number. So this one must match that one, must match this one. Maybe we can't. We can use letters here. Oops. So this has to be the same as this. We're not sure what though. Um. Hmm. It's also the same here. Obviously, it can't be all four of these. So therefore, at least one part has to be the same. Has to be the same region as the pink, right? Hmm. Hmm. So this points this way, which means it's either both of these or it's one of them. This, we're not completely sure. Oh yeah. It must include two, right? Because it can't be the same one, right? Because it can't just be one. So it must at least include two. It cannot include four because the minimum there would be 1 plus 2 plus 3 plus 4, which would be 10, which is not valid. So it's two or three. Hmm. Um, hmm. So that's for this one going that way. This one, oh, even worse. It cannot have it's obviously less than 4. So it's 3 at most. It can't be 1. So it's 2. Well, this is also 2 or 3. Oh, that's interesting. So say these were the same. Well, I guess it could be, right? It could be something like that, and then it counts 2. And this would count 3. That's possible. Hmm. Yeah, what does that mean, though? Interestingly enough. That means this is at maximum 17, which means the cells outside the region add up to 17. So the cells in the region have to add up to 45 minus 17, which is 28. If they're the same region, they don't have to be the same region. Hmm. Oh, wait. How does, yeah. Well, I guess it could go something like this, maybe. So it'd have to be something like that, which is doable, right? Hmm. That's the only way it can go, right? Because you can't go this way because we know these two can't be part of the same region, and this one has to get to be has to have some part of the region be in these cells. This also has to have some part of the region be in these cells. It would be easiest if they're the same region, right? So then that adds up to the ones outside of that region add up to at most 17. But we don't know if that's the case. So that's those two. That's the interaction. So this one we've used. This one we don't. We've seen the interaction. What about this? This could be one or it could be both. It could be counting both. This could be counting 1, 2. I can't be counting 1. It's 2 or 3. Okay, so let's say what these are counting. So this is counting 2 or 3, and it's also A. So we know it's okay. Let's use outside this. That's hard to see, but anyways, this is counting. Okay, let's do it the other way. This is A, and it's counting 2 or 3. This is also This is counting also 2 or 3. This is counting 2 or 3. This is counting 1 or 2. This is counting 1 or 2. This is counting. Oh, this has to count 2. You can't count. So this has to count 2. This is counting 1, 2, or 3. This is counting 1, 2, or 3. This is counting, could be 1 through 5. This is counting 2 or 3. This is counting 1, 2, 3, or 4. This is counting 1 through 6. So this is up to 6. This is up to 5. So we're going to go 1 through 6, and this is going to be 1 through 5. This is also 1 through 5. Because I could technically 2, 3, 4, 5, 6, 7, 8. Actually, it's 2 through 6 here. So it cannot be 1 through 6. It has to be at least 2 through 6. Okay. What does that mean? The ones that have to be at least 2 must be at least 3. This is at least 1 or 2. This has to be 2 digits. So this has to be 3 at least. This has to be 3 at least. We know this is also 3 at least. So let's delete the middle. So this is 3 at least. This is at least 3. This is at least 3. What does that tell us? Not really sure. Okay, let's not make this A. I guess it's just easier to make colors. Um, hmm. What does this mean? Okay. Hmm. These are the same. Oh, that's actually interesting. What happens if these are different regions? So if, first of all, then it would have to, this one has to be the same region as this, because this needs to be, this region needs to actually be here, and this region needs to somehow be here. And the only way that happens is if this is the same region. So say it was something like this, along this lines, right? What does that mean? That means this number must be the sum of this number plus another number at least. And this number must be the sum of this number and another number at least. Which is, it technically is impossible. So therefore we know these two cells have to be the same region. Does that make sense? Okay, so say let's use actual numbers here. Say this was, I don't know, a 6 and this was an 8. This 8 would have to be the sum of this 6 plus two other numbers. But so would this 6, because it's the sum of all the numbers that are not in its region. So the 6 would have to be the sum of 8 and some other numbers, and that's impossible. So we know from that deduction, these two have to be the same region. Therefore, all the other digits that are not in the region must be must add up to at most 17. So there's at least two here. There's at least two here that are not. Sorry, there's actually at least. There's at least one more in this region here, in one of these four. There's at least one more in this region for. Well, actually, I guess it could be. There doesn't have to be one more there. But there's at least one more for the pink region to be in one of these four, because you cannot have all four, because it'd be 1, 2, 3, and 4, which would add up to 10, which this number is not allowed. So these two are in the same region. The head of the arrow. Okay, so then this is not the same. It's center only. So this is a border. So if this ever goes to this end, it has to be something. Actually, it would have to go like this specifically, because you cannot. So to have this part of the region, the problem is you need at least two to be not in the region. So therefore, these would have to not be in the region. Therefore, it would have to be something along the lines of this, right? So therefore, these would be part of this gray region, because otherwise, there's no other one it can be part of. Right? Because you can't have 9 digits now, all blocked by here. What does that mean? This is 2. So that works, actually. Actually, one thing we know is this has to be a border. We know that for certain. Because we know this can't be the same as either one by itself. So it has to be the same, it has to add up to both of these. Okay. So say it did go something like this. These would have to be gray. What does this mean? So then this would be the same as those two summed up. But this would be the same as those two summed up. And then we have the same problem that we had here, right? So it looks like one of the key break-ins is recognizing arrows pointing at each other leads to some problematic issues. Unfortunately, now we've run into both of them now. So this is the only one these are the only arrows that are pointing to it. These are the only arrows that are pointing to each other. Therefore, they cannot they cannot be part of different regions. Right? Because this then has to be the sum of this plus another number. I guess... Yeah. Okay, hold up. It's technically possible for them to be the same number. And then the other digits in the... So it could be something like this, crazy enough. And then these two are the same digit. So that's possible. This didn't work because it's obviously regular Sudoku rules disallow that. But the only way these two could be part of different regions is if you have a region in between for both of them that add up to that. No, that doesn't work. Right. Yeah. Yeah, that okay, so no, that doesn't that I was thinking something cool, but that doesn't work. Um when can these ever be the same, essentially is the question. They have to be, if they're assuming they're different regions, can they ever be the same? Well, actually, can they ever be the same? Because if they're in the same region, they can't be the same, obviously. But they have to be. I don't think they can ever be the same. If you have this be the same as this, that there have to be different regions, first of all. So therefore, both of these. Oh, I guess. Okay, so I guess it could be something like this. Maybe that works. 1, 2, 3, 4, 5, 6, 7, 8. This, no, because this, okay, yeah. So then these cannot be the same. So if this is the same as this number, if this number is the same as this number, it must equal that number exactly. So therefore, these two must be part of its region. But for this number to equal that number, they must be part of different regions, and it cannot, and then therefore this must be part of its region, which so therefore this is now part of two regions which are different, so that's not allowed. So they can never be the same. We know that for certain. Therefore they must be different. Therefore you're saying this must be the sum of this. If they are part of different regions, you're saying this must be the sum of this and another digit, because it can't be the same number. We've already shown that. And this must be the sum of this and another number, which is not allowed. Because so then this would equal the sum of this plus another number, and this would be the sum of this plus another number, and that's an inequality you can't have in math. So that basically these must be part of the same region. That's very clever. I like that. So therefore, well, it's very similar logic to here. And once you figure this out, it's fairly easy to figure this part out from there. So these two must be part of the same region, which means this one cannot be part of this region. Because if it is, then it would essentially, this would be add up to 0. And you cannot have that. So therefore, this must be a different region than the green. So we're going to make that light. And then on top of that, this must be a different region than the green one, right? So this either connects this way. I guess it could connect something like that. Now, the pink, it could actually be part of pink too, so we don't know that one specifically. This one could then connect that way. So that is possible. Therefore, we know this one has to be less than this. So this has to see specific... Okay, this is exactly the same as this one. So we know this one matches... not that. This one matches this. And this one must be the sum of these two. Oh, that's interesting. This has to be at least 3. This is the same as that, which means it must be at least 3 also. Because this must be at least 3 because it adds these two. And they cannot be the same as just one of this. Therefore, this one is adding this and this. This has to be at least 3, because it's adding at least one of these two. This is adding at least those two. So this has to be 3 through 6. This also has to be 3 through 6. Because these two added together must add up to this. So this is 7, 8, or 9. This is 3 through 6. This is 3 through 6. What does that mean, then? I'm not really sure. This cannot be part of the same region as pink. If it does, basically it would be like this, right? But the problem here then is this then has to get out, so it would have to be part of this. This is a different region, so this would have to be pink, and we have this number equaling that number, which is not allowed. So therefore, the green region has to be different. So therefore, this has to be a different region. That's very clever too. Wow. This is a lot of very cool stuff here. So this one is the same as this, plus something. So this can never be 6 anymore. It can't be 5 either. This one has to be greater than this. So this can't be 3, which means this can't be 3. So this is the same. So this one adds these two plus that, or these, yeah, this one adds these two, and which this one adds up to this plus another number. So this is at least 4. This cannot be 6 anymore. So it's at least 2 doubled plus 1 or 2. So this could be... So this is 3 or 4, no matter what then. Because this has to be 3 or 4, which means this is 4 or 5. So we know this is either 1, 2, or 1, 3. So the 1 has to be here. Can it go this way is the question, right? If it does go this way, this would have to be 6. So this would be 6, this would be 6. This would have to be 3, 3. This could be a completely different section. So then this would have to be 1, 2, 1, 2. This would obviously be 1, 2. So then this would be 9, if that's the case. So this couldn't be 3 or 6. This would have to be part of this. So it would have to extend out here. Yeah. Because this is the only region it could be connecting to. Because it cannot be part of the green because we already have a 1, 2, 1, 2 pair there. So this is 6, this is 6, this is 3, this is 3, this is 9. This needs to extend out because there's no other place for it. This seems okay. Actually, technically, this could be part of the pink also. So this works so far. This would have to be 9. And then the 4, 5 would not be part of it. So 7 and 8 would have to be part of that, if that's the case. This would have to either be... That cannot be 9. So then this would have to be part of the pink. And because this is part of the pink, that means this gray would have to also be part of the pink. because it has nowhere else to go, because this one has to connect here somewhere, and that if this can't be part of green, and it would not have enough to form its own region, therefore it has to also be pink, if that's the case. This could be the same as this one. It could also be the same as those two added together. Okay. This might actually be the solution. We were trying to find an impossibility going down this path, but this is actually looking decent. Let's try going down the other path for now. So say it goes this way, right? Oops. Oh. Huh. So we said let's try going this way. It cannot obviously be this and still have like this, because this would be blocked. Therefore, if it goes this way, interesting. So if it goes this way, these are obviously all part of a different region than the peak. So therefore, this would have to be 6. But if it goes this way, in some way, this blocks the pink from ever going here. So therefore, this would also be not part of the same region. Therefore, yeah. Therefore, we know either way, whichever way it goes, this has to be 3, and this has to be 3, and then this has to be 1 or 2, and this is 6. That is cool. And then this has to be 6, and therefore this is 9. Wow. Wow, 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 wow. That is pretty cool. In addition, so if it goes this way, this one has to be part of this, and therefore these two have to be... Can that actually work, though? If you try going this way, these are different. But we know this adds up to 3, and this adds up to 3, and this is the same number. So these have to be the same number, which is not allowed. Therefore, this way doesn't work. So therefore, you cannot go this way. You have to go this way. And I was right in my deduction, or like my hunch. Because basically I was like, wait, this seems like it's actually working. So therefore, what happens here? And it looks like that's a solution. Again, so if you go this way, if you go some way or whatever, which way that goes blocks this way, we know this one has to be a different region than this one, right? So this one has to be the green. This one has to be the same as the dark gray or the medium gray, because it doesn't have anywhere else to expand to. But then the thing is, we know this adds up to 3 because this says that, and this adds up to 3 because this says this is 6 minus 1, 3, 1, 2, and 3, because we know these two add up together have to form that. So this is at most 6 because this was at least 3. So therefore, this adds up to 3, this adds up to 3, this is the same digit, therefore these must be the same digit. So if this was 1, these would both be 2. If this is 2, these would both be 1, therefore they cannot be part of the same region. Therefore, this does not work. Therefore, the green cannot go this way. It must go this way, right? And it cannot be like this, because then what region does this belong to? So it cannot avoid this as part of the green region, because where else would it go to? And then it cannot go out this way, so it can't avoid that because it needs to connect somehow to the 9. Therefore, it must go this way. Therefore, these are all part of the same region. This cannot be part of the same region as green because we already have a 1-2 pair. Where does the rest of the region go? It must go to here. So therefore, these two must be medium dark. Wow, that's really cool. That is really cool. This is 4, 5, 6, 7, 8. This can't be 3. It can't be 6. This also must add up to at least 2 digits, which are not part of the region. We already have 1, 2, and 3 taken care of. The minimum, therefore, is 4 and 5. That cannot be part of the region, and therefore this must be 9. So this is 9. say this, and this can no longer be 9. Therefore, this must be the same region as this, which is purple. This can't be part of green, so we know this is separated. We know, again, if this encloses some, it has to enclose somewhere, right? And this is not part of the pink region. Where does this go? It can't be part of green, and it can't form its own region of 9 squares, 9 cells. Therefore, the gray is part of the pink region too. So this is 1 or 2. These are different. Therefore, this must be either... Okay, this could be green. So, but this is part of pink. So this we know is gray because it has to extend. It needs 9 cells. So where can it go? It has to go here. The pink has 2 other cells here, and then also there's 2 other cells that are not part of pink. Probably gray is part of it. We don't know. Okay, so then this is a boundary. This is a boundary, obviously. This sees 1 or 2. And it cannot be 3, 6, or 9. It cannot be 1 or 2. So this is 4, 5, 7, or 8. If it's 4, okay, so say this was green, right? This would have to be at least 4. So this would be 4 or 5 or 6 or 7. If it's 4, this could be 5, and that could be 1. Or this, so this would have to be 1 through 4, right? To add up to potentially 8. Because this is at minimum 4, this is 4. This seems possible. Hmm. So this can't be 6. We know the rest of this is 4, 5, 7, 8. Oh, that's interesting. Hmm. Hmm. Okay. One thing is that we know is wherever the 3 is on the gray. So this is 1, 2, 3, 4, 5. I guess it could maybe could end that way. That's possible, actually. Never mind. I was gonna say that the 3 had to be part of the gray, but it could go something like that. Oh no, this is not possible. We know 2 of these are pink, right? What's the minimum that connects these pink? 1, 2, 3, 4, 5, 6. It cannot essentially go out of its way to do that. So say we tried to make this pink. How is that possible? So we'd have to be something like this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But these are not orthogonally connected. Therefore, this cannot be pink. Therefore, this is some other... So it could be gray, but we're going to make it orange right now. Say this was pink. We'll try doing that. 1, 2, 3, 4, 5, 6, 7. Without these 2. Okay, well... Let's try that then. So say something like this, right? 1, 2, 3, 4, 5, 6, 7. This would have to be 8 and 9. So this is not allowed. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that doesn't change no matter if you make this one the pink or this one the pink. Therefore, we know which ones are the pink. This has to be different. These have to be different. Therefore, this is the 4 and the 5. Oops. Therefore, this is the 4 and the 5. This has to be 7 and 8, and both the pinks are here. Therefore, this one has to continue out here. because you need 9 digits. This is a boundary. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's possible still. So it goes either here, connects here, or it goes here, it connects that way. Can it ever be this? So 1, 2, 3, 4, 5, 6, 7, 8, 9. No. So it cannot extend from this way without... So we try to avoid having this be part of the pink, right? So that's going this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, because that's not part of the pink. That is part of the pink. Therefore, this one has to be pink. We don't know if it goes this way or if it extends here and then extends here. So this also we know is a boundary. Then 2, 3, 4, 5, 6, 7. So it cannot be 8 and 9. So this one's not gray. So we tried to have... actually, I guess it could be gray, and this would be a different one. Never mind. We just know that they're different. Yeah. And this could be green again. This could be 9, and then this would be 1 or 2. So say this was all part of one region. It's not possible. So these two have to be separate regions. Right? Because... Okay, first of all, yeah, so then you cannot have... Okay, the only way this is pink is if this region connects this way, right? Because this is too many. If you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, wait. In addition... Okay. So we know this cannot be 7 or 8. If this is 7 or 8... Yeah, it's part of the pink region. We already know the 7 or 8 has to be part of the pink region. Therefore, this can't be 7 or 8. So this is 4 or 5. If this was part of the pink region, so say this was part of the pink region, this would have to be... We have 5 here. This would be 6. This is 7, 8. There's only one cell remaining in the pink region. Therefore, it would have to go here. But then, therefore, these would be the same. These would be pointing to the same cell. And they would have to be the same number, which is not allowed. Therefore, this cannot be part of the pink region. This is part of another region. It could be gray. 1, 2, 3, 4, 5, 6, 7. 8, 9. Wait, hold up. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it cannot be part of gray. It has to be part of another region. I'm going to make that orange. So therefore, this is the sum of those two. It can be 8 or 9, but that means this is 1 or 2. Interesting. So this cannot be 1 or 2. Actually, it could be 1 or 2. Huh. Oh, it can't be 1 or 2. No, because of this 1 or 2. Therefore, it cannot be 1 or 2. That means this is not part of the region. The only region it can be part of must be green. Therefore, it's this way. Therefore, this is the sum of these two. This is at minimum 4, so then this has to be 1, which makes this 5. So this can't be 4. These are connected this way, and we have the pink region. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 1, 2, and 4. Neither of these can be 4. Therefore, this must be the 4. Therefore, these are 1 and 2. So we have the pink region. This is 8 or 9, adding to that. This has to be 2 then, which makes this 1, which makes this 2. Okay. The green has to go out somewhere, because this is at minimum 5, 6, 7. So this has to be green. This cannot, well, it could be add up to just 1. That's fine. This adds up to 2. So it's 2 of those. Okay. Let's just do the border. Let's see. This is obviously not equal to all of this. So far, right, it cannot be part of any of these regions. So this is at least 3. So it cannot be 1. It's 3, 4, or 5. Can it be 5? This is at minimum 2. So you could have 2, 3, 1, 2, and that could be 1. So it still could be all 5. This is at least 6. 6, 7, 8, or 9. This has to contain interesting. This is that neither of these can be part of this cell or this region, wherever this region is. So this is also at minimum 6, 7, 8, or 9. So it can't be 2. It's at least 3, 4, 5, 6. This, hold up. This has to be 2, 3, and 2. Or sorry, 1, 3, 2. Which would make that 2. This could be 1. So that would be 7. This is at least a 3. So this could be part of this region. So this can never be 6 then, right? We just saw, so this is 1, 2, 3, plus 1. That's 7. This would be 10. So this has to be part of that region if that's the case. Therefore, it's 5 at most. But we know this is 6, 7, 8, 9. Therefore, we have a 6, 7, 8, 9 quad in column 7. The rest has to be 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Therefore, one of these must be 6. And one of them basically is counting 3, only 3 of them. This obviously can't be 1 or 2. This can't be 4 or 5. Interesting. If this is 6, that means this does not count this one. So the only way this counts this one sorry, the only way this cell counts this one is if they're not in the same region. And this would have to be 9, and then therefore this would be 6. This can't be 1, 4, 5, 6, or 9. So this is 2, 3, 7, or 8. Okay, what are these? This is 4, 6, 7, 8, 9. This can't be 1, 2, 3, 4, or 6. This is 5, 7, 8, 9. These can be 1, 2, 3, no 4, 5, no 6, 7, or 8. Can it be all 4? It'd be 4, 1, 1, 1. Yeah, possible. Not likely, but possible. This can't be 4, 5, or 9. It's 3, 6, 7, or 8. It can't, well, it could be 3. This could be part of the same region. Wait, can it? Hold up. Is this ever the same region as this? If that, is this never the same region as this, is the question, right? Can you ever have this not be the same region? No, because it has to connect this way then. Or this way. I guess it could be 3, right? It could be... Okay, yeah, it could be. It could be 3. But this can't be 3. Sorry, this can't be 1 or 2. So this is 3, 4, 5, 6... No, 6. 3, 4, 5, 7, 8, 9. Can this be... It still could be 1 here, right? So that is possible. So it could be something like this. That is doable. Hold up. I guess it could be part, yeah, something of another region, right? This could be 9, and then these two are part of separate regions. So then it would add up to 3. This would be 1. That seems reasonable. So one of these is 6, which means one of these is whichever one is 1, none of the other cells can be added to it. Interesting. What does that mean? So say this was 6. If this is 6, that means all of these cells in some way have to be the same region. So you would have to have something like that, right? This could not be 6 anymore. This would be 7, 8, or 9. So then this would be 1. This would be 2. Hmm. Um. Hmm. Hmm. Can this ever be 3 anymore? No. Right? Because if it tried to be 3, where are the 2 digits that it adds up to? It would have to be 1 and 2, but this can't be 1 or 2. This can't be 1 or 2. This cannot be 3 then. Can it be 6? Possibly. It could be 5, 1. Okay, this is never part of this region. So these two are always different regions, right? So say you tried to make this. It would, yeah, you can't. Because this has to be part of gray if that's the case. So these two are never the same region. Right? Um Say you tried to make these two the same region. We know 2 of them at least have to be different regions, so therefore it would be like that. Therefore, these 2 would be blocked. So this can never be the same region as this. Can this ever be the same region as this? No, because of the same problem, right? You need to have 2 that are not part of the same region. So therefore, neither of these 2 are part of the same region as this. So this has to be at least 7. So this cannot be 7, 8, or 9. It can't be 4. This can't be 4 or 5. It has to be 3. Right? If it's 4 or 5, these 2 are never part of the same region as this. So therefore, this would add up to 9, but that's not possible. So this has to be 3. Which means this cannot be 3. That's 3 in the corner. We celebrate. This is 4 or 5, so it cannot contain both of these. So it cannot go... But it could contain neither. So neither of these are part of this. This could be part of this, though. So we don't know anything about that. This cannot be the same as gray. Because this is at most 9 stops here. This could be 3 here that are not part of this, which would make this 8. Hmm. Okay. This still could be 1, 2, 3, or 4. This is 3, 4, 5. This is 3, 4, 5. One of them is 6. That's interesting. So say this was 8 and this was 9, right? Oh, that's not, huh. Okay, we might have a okay, so say this was 7. This would have to be 8, but then that would have to be 8. So this can't be 7. Okay. So this has to be 8, which makes this 7, which makes this 9. Okay. That helps a lot. Hmm. Okay. This is 6 or 8. This is 6 or 8. Which means this is only 3 or 4, and this is only 3 or 4. We figure that out because one of these must add up to 6. The other one must add up to 7 in 3 of them, and therefore the other one can only have a 1 essentially added to it. Right? Therefore, this only adds 3 or 4, which means so this must be the same as at least 1 here. This must be the same as at least 2 here, right? We also know a 1 is somewhere along these diagonals. We're not sure where. Cannot be here. Cannot be here, obviously. Oh, this can't be part of this one, right? Because if it's 3, it would have to be 8, 9 here, and this is not part. So these two are, sorry, these two specifically have to be part of the same region. If this was a different region, this has to be a minimum 3. Therefore, there's a minimum 6 here, so that adds up to minimum 9, which is not allowed. So these yellows are the same. What else do we have? Hmm. This is 1 to 5. Hmm. Unlikely that it's 1, but that is counting 1. Excuse me. This can't be what? So this is 4, 5, 7, 8, 9, but obviously no 9. This is 4, 5, 7, 8, 9, but no 8. This is 4, 5, 7, 8, 9. It could be any of them. So this one still could be the same region as these two. So we don't know anything about that. Um, say that were the case. We know, huh? Is that possible? We know only one of... If this is if this is the same region as these two, you have 1, 2, 3, 4, 5, 6, 7, right? Only one of those is not the same region as the other yellow. I guess that's possible. Right? So something like this. 1, 2, 3, 4, 5, 6. Then you have 7, 8, 9. That is possible. And then this would be 1, right? Okay, never mind. So that is still possible. Okay, so one interesting thing is there has to be a 1 either here, here, or here that's not part of yellow. I mean, it could be part of yellow. It's just not part of either of these two regions, whichever ones they are. Okay, let's do this. This is 1, 2, 5, 6, 7, 8. So this can't be 1. This is 1, 2, 5, 6, 7, 8. We have 1, 2, 3, 6, 7, 8. 1, 2, 3, 6, 7, 8. So obviously these two can't be 8 because of this 8. Hmm. Hmm. Okay, so for this cell, we were saying you could have 1, 1, 4, and 1. That's not possible, actually, because one of the ones has to be here. So this can only be 2 of the ones, and this would obviously be 1, and one of these would be 1. But you could have a 2 with it. So 1, 2, 4, and... Okay, so that's still possible. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9. It'd be possible to be there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these would both have to be green. Yeah, I think it's very doable. Oh wait, I was thinking of something else. Never mind. That. Yeah, you can't be all four of them are the same region, right? Uh, this has to be the same region as this. Why? Because if these are different regions, this would have to be 2, 1, 3, and 2, and this would be 8, but this being a 1 forces this to be a 2, which would mean this is 2, 3, and 2, which adds up to 7, and that's not possible. So these two have to be the same region also. We're running out of colors. Um, And again, the blue could be the same as the yellow region. We don't know. Mm-hmm. Hmm. Hmm. Uh, okay, this gray, where is it going to get the 3? It can't get it from going that way. So this is the only possible 3 that it can go. So this is 3. The gray could go here, or it's green. We don't know which one. That means one of these two at least, or both, are not gray. This has to be 5, 6, 7, or 8 also. 1, 2, 3, 4, 5, 6, 7. This is at most 8. So it could go here or it could go here. Hmm. Okay. Hmm. Hmm. Um. Hmm. What does this mean? Hmm. Kind of stuck here, actually. I'm not sure how to approach this. Obviously, these two are different. The question is, is this the same as this one, or is it different? We don't know. We know these two are the same. We know those two are the same. We don't know if all 4 of these are the same. So that's using this arrow and this arrow. That's using that arrow. All of these arrows are already used. This one This doesn't seem like it helps much there. Hmm. Hmm. This is at most 8 now. If it's 8, I guess it could be 2 1 1 1 1 or 2 or whatever. Yeah, that's still possible. Right? 2 1 1 and 1 or 2 or 1 or 3. Technically, it's very unlikely that it is. Right? So to do that, well, they just have to be different ones. That's all. Okay, I need to go to the bathroom. I'm going to be pausing for a little bit. We'll be back right after that. And I'm back. Let's see. Where were we? 7 or 8. It still adds up to 2 or 3. Right. We were trying to figure this out or this out. And then this too. Hmm. Hmm. Let's make this dark. And we'll make this orange. But they could be the same. Hmm. How many can this actually see? So 1, 2, 3, 4, 5, 6, 7. Can I do something like that? 8, 9. No. So it has to at least be 4, 5. So it cannot even go down to here, right? 1, 2, 3, 4, 5, 6, 7. Right? Because then it would have to be 8 here and then 9 here, but that's not orthogonally connected. Therefore, this can never be part of the same region as this one. So this is a separate region as this. So we're going to make that red. Therefore, this cannot be 2 or 3. This has to be 7 or 8. So this is 7 or 8. This is 7 or 8. That means this can't be 7. This can't be 7 or 8. So 6 is one of those two. The blue could be part of the gray, or it could be part of the orange, right? So this is 7 or 8 because it must contain at least a 4 in that row. It still could be, so it has to have at least 2. So it's not 1. It could see all 4. It could be 4 and then you have a lot of 1s. What else? Hmm. If blue and yellow are different, that means this has to be 7, 8, or 9. Okay. Okay, so yeah, we also know this cannot be part of this blue. It's likely red, but we don't know. Let's make it brown. It's likely red, though, but we don't know. So this is not blue. The only ones in question are these two, right? So this red can never be part of the green. You have green 1, 2, 3, 4, 5, 6. Oh, it could be part of the green. 1, 2, 3, 4, 5, 6. Oh, no. 1, 2, 3, 4, 5, 6, 7. There we go. 8, 9. So that's the furthest it can get to. So it cannot be, the red and the brown cannot be part of the green. They're likely part of the same region. Um, hmm. So we were saying what happens if the blue is the same region as the yellow, right? This would be an example of it, right? 1, 2, 3, 4, 5, 6. You just need to connect in ways that allow that would be valid. Therefore, this would be 7. This would have to be 1, 1, and 1. Oh, that's actually interesting. Huh. If these are the same regions, so say we try to make these the same regions, we need 3 connectors, obviously. Obviously, this one would have to be because it's surrounded by yellow. And you would need to be either connecting here or here, or here or here. So that would count for 9 of them, right? So therefore, none of these could be yellow, which means that all 4 of them would be different regions than the yellow. This would be 6 and 8, which would force this to be 7. And if this is 7, this would have to be 1, 1, 1, and 4. But the problem is, these 1s would eliminate all possibilities for 1s in the purple region. Therefore, this is not possible. Therefore, yellow is different from blue. We know for certain yellow is different from blue. Therefore, this cannot be 3, 4, or 5. This has to be 7, 8, or 9. So it could be 9, and this is 6, and this is 8. What I think... Huh. Interesting. That was actually pretty... Huh. I don't know how you're supposed to see that, but... okay. There's restrictions that you have. This is 7, 8, or 9. These are different now. We know these are different. Therefore, you could have something like this. I mean, you could technically even have something like this. That would be 1, 2, 3, 4, 5, 6, 7, 8. Now we go through the possibilities that these could be, right? So if this is 6, can this ever be 9 is the question. And then you have 2. Probably. So we know it's 2 or 3, right? So say this was 9, and this was 6. So therefore this would be 8, which would make this 1 and this 2. And there would have to be a 1 in between. Okay, that doesn't seem to do anything there. What happened? Okay, so let's make this 7, which would make this 8, which make that 6, which makes this 8. So this can't This could be 7. This would have to be 1. This would be 2. This would not be 1, so this would be part of orange. This would have to be 4. This would be 5. This can't be 8 anymore. Still seems reasonable. We know there's a 1 in one of these 3 squares. We don't know which it is. There could be more than 1 also. But we know there's at least 1 in one of those 3 squares. Hold up, if this is 1, this has to be 2, and then this would be 1, which is not allowed. Ah, okay. So this one can't be 1. If this was the 1, then this becomes 2, and this is 1, but then you have 7, 7, which is not allowed. So 1 has to be one of these 2. Therefore, this can't be 1. So either this is 1 or this is 1. And it would, okay, so if this is the 1, it would have to obviously go somewhere around here because it cannot cut through here. Oh, interesting. This also sort of uses a yin-yang issue. Huh. But basically, if this is the 1, it goes through here. If this is the 1, it cannot go through here, so it would have to go through here. Interesting. I mean, technically, it could go something like this, right? This is 2 or 3. Which means that could be the yellow. Unfortunately, that doesn't, yeah. I mean, heck, it could even be something like this. It's unlikely, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. It cannot be that. It would have to be something like this. Because you need, again, these to be countered, or these to be the same. So say this was 8. If this was 8, this is 6, which makes this 7. This has to be 9 then, which makes this 8. So then this adds up to 6. So this is 1, this is 2. There has to be a 1 here. Okay. So these are all yellow, if that's the case. This can't be 2. This can't be 2. This can't be 2. This can't be 8. Can't be 7. Ah, we have a contradiction. This is a different one, so therefore this cannot be a different one. Sorry, these cannot be the same as this one because this is blocked by this. And therefore, these... we already have these two adding up to 7, and we know these can't be part of this region, therefore it's more than 7. So that does not work if this is an 8. So this cannot be 8. So this has to be 6, which makes this 8. This can't be 8. So this one is all part of the same region. Therefore, the 1 cannot be here. Therefore, this is a 1. And it's not part of the region. And this isn't part of the region. So this is 1, which makes this 2. The 1 cannot be here anymore. The 1 cannot be here. Therefore, these two are part of the same region. Because if this was not part of this region, it would be 2, 3, and 4 at minimum, which would mean this would have to be 9. Okay, so then this becomes 1, 5, 6, 7, 8, and 9. So this can't be 6, this can't be 1, this can't be 8. This is part of the same region. This is not part of that same region. And this also has to be part of the yellow. So we have 1, 2, 3, 4, 5, 6, 7 at least. This could be part of some other region out here. We don't know. 1, 2, 3, 4, 5. Okay, so this can't be 8. This can't be 8. This can't be 6. This can't be 8 because the 8's here. This can't be 1. So 1 is one of these 3. This is part of a separate region, which means this is at least 2, 4, and 1. So can this ever be 3? If this was 3, this is 2 and 4. That would be 9. Therefore, that's not possible. Therefore, we know the 1 is over here. So this is 1. This cannot be 6 because of the same reasoning. So therefore, this is 4, which means this can't be 4. This can't be 4. This could be 2 or 3. We don't know which. This can never be part of blue. So this is also not part of blue, which means this is 1. This has to be 2. Therefore, this is 8. This is 7. Therefore, this is 4, and this is 5. So this can no longer be 5. These can't be 2. This can't be 8. Okay. This can't be 7. These can't be 1 now. Where is the 1 in yellow? I guess it could be down here. We know these are all different regions from this. Therefore, this is 8. This is 6. These have to be different regions. It could be yellow here. This is not yellow. We'll make it purple, I guess. It could be blue. This could be blue. We don't know. These can't be 2. This is 3, 5, or 7. Interesting. This can't be 1. This can't be 1. This is never part of this region. It just can't, it can't make it there, right? 1, 2, yeah, this, first of all, if this is yellow, this can never be part of this region. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, can't even reach it. This is maybe not. 1, 2, 3, 4, 5, 6, 7, 8, 9. But then these 2 yellows are out. So this is not part of the region. Therefore, this can't be 8. And, well, that's all we know. This can't be part of this region because it would be yellow. I think yellow, being part of yellow is like this can so say this was not part of yellow. If this is not part of yellow, how does this work? And still going through. So if this was going through and it's not part of yellow, this has to go 1, 2, 3, 4, 5, 6, 7, 8, 9 already to go around. So this cannot be part of yellow. If it goes through and it's not part of yellow, this is never part of the set. It can never be part of the set, even with yellow. So that's out. What about this? I think it's the same, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So that also is the same. I think this has to be part of yellow, right? If it's part of this one, whatever this is, and then goes here, I guess it would be like this. It's the same problem, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. It never gets actually to the yellow. So therefore, this has to be part of yellow. If it's not part of yellow, okay. Say it's not part of yellow, but it doesn't cut this off, right? It doesn't block this. What's the minimum here? 2, 2, 1, 1, and 2. So that's 8. But this can never be 8 or 9. So that doesn't work. So it must actually contain one of these two, which would mean if it's not part of yellow, it's blocking yellow, and therefore yellow would not work. Therefore, this must be part of yellow. So this is part of yellow. It must contain one of these two, because if it doesn't, this is 2, 2 at minimum. And then this is, okay, this can't be 2, but this would be 1 and 1 at minimum. And then this would be 2 at minimum. So then this would be 2, 3, 4, 5, 6, 7, 8. So that's not possible. So one of these two at least is a yellow. We don't know which. Could be both. If they're both yellow, this is 1 and 1 at most. So this cannot be 6. Sorry, 1 and 1 at least. This has to be 5, then. That could work with 7, but 6 cannot. This can't be 6. We know these are not yellow. These are not yellow. So actually, we're going to make it... No. We'll make it dark green, forest green. So therefore, these are not the same as this. So we know... Okay, so this one is the end of a boundary. If this was 6, this would have to be 1 and 2, so that's 9. That's not allowed. So this can't be 6. If this is 5, this is 1 and 2, and therefore that would be 8, and this is not allowed, so this can't be 5. This is 1, 3, 1, 3, which forces this to be 6, which means it cannot be blue. So this is a separate color. I don't know, we'll make it ochre. So it cannot be blue because we already have a 6 in blue. This can't be 1, 2. Could be 3, 4, 5. No 6. Could be 7. Cannot be 8. Could be 9. Okay, so in addition... So these... Okay, what's the minimum that connects these? It would be 1, 2, 3, 4, 5, 6, 7, 8. So we know these two can never be part of yellow. So this one has to be part of the yellow. Right? So therefore, this is 1 and 2. Which means this is 9. So this can't be 1 or 2. It can't be 1. Huh. This has to be 9. But we need another yellow somehow. Huh. That's problematic. This has to be 9, then. We already know. Yellow does have to go here. So yellow has to go here. And yellow has to be one of these two. So 1, 2, 3, 4, 5, 6, 7, 8. Four, 5, 6, 4, 5, 6, 7, 8. We have a problem. This is already 8. It can't reach here. Not good, not good, not good. Shoot. I think we have to go back to on our logic here. What did we miss? What did we miss? We had. Is there another way? I don't think so. Right? That's a problem. That's a big problem. I mean, could this go all the way? I can't, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the minimum. And if it's part of yellow, yeah, this has, I mean, there might be something wrong with my logic up there. Uh, yeah, I'm just running into an impossibility here. So this crossing with this is problematic, right? Four, five, six, seven, eight, nine. Yeah. Hmm. Ugh, that's not good. Hmm. Hmm. So again, if this is either 7 or 8, this is 7 or 8. If this was 7, that would force this to be 8. Right. This has to be 5, 4, and 1 because this can't be anything but 4. This has to be 6. This is 7 and 8, so therefore this can't be 7 or 8. Therefore it's 5. Therefore this is 4, and that's 1. Which makes that 2, which makes that 1, which makes that 2. So this has to be 1 and 7, or 1 and 8. If this becomes 1, 7, this is 8, and therefore that's 8, which is not allowed. Yeah, this has to be 7, 9, which forces this to be 6, 8 pair, which forces that this can't be 1 because of this. So therefore, if this was 2, this would have to be 1, 3, 2. This would be 8. If this was different than this, then that would be 2, 1, 3, 2, 8. This would have to be 2, though, because of the purple region. and therefore this would not add up to 6. So this has to be part of that region. This has to be part of that region for the same reason. And maybe this logic is the incorrect one. So we said if these are the same region, they have to connect somehow, right? So 2 out of these 3, I guess it could be. Oh, that's where I went wrong. So because of all the prior logic, this has to then be the same region. Because we ran into a problem where basically this was having issues with this. But we only assumed what happens with these these cells were the correct one. What if this was the correct cell? Then this could be a 7, right? Then this could be 7. This could be 1 or 2. This could be 1 or 2. It can't be 2. So this is 1. This would have to be 4. This would have to be 2, which would force this to be 1, which would force this to be 2. This would not be 7 or 8. It could be 3, 4, 5. It could be 9. This can't be 7 or 8. This can't be 2 anymore. So this one has to be the 8, which would force this to be 6, which would mean this is also part of the yellow, which means this is not part of the yellow, and it's 1. Okay, so this is 2, 3, 2, and 1. This is 1, 2, 3, and that's 6. This is part of the region. Now we connect these. So it's 1, 2, 3, 4, 5, 6. This must connect with these somehow. So it's either one of these two. So if it connects there, then this must connect with this. So this has to connect with this. I guess it could be here. This, so say this does not connect this way. It has to go around, and then this would have to be yellow. So either way, this is yellow. So this is yellow. So this kind of works. Yeah, this does work, actually. So this can't be 2. This can't be 1. How did these connect? If you connect here, so you have 1, 2, 3, 4, 5, 6, 7. You cannot have one thing that specifically disconnects it. So one of these two must connect, obviously. Both of them could connect. Either of these could connect, right? But if this is the case, if it connects here, it has to connect here. If it connects here, it has to connect here. If it connects here, it must connect here. So one of these two at least is connected. We don't know which though. So this can't be 1. These can't be 1. This can't be 7. This can't be 7. Therefore, this is 8, and we don't know what this is. So this cannot see any of these. It cannot get there. 1, 2, 3, 4. It has to go around the yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is locked. These 4 are locked. This one has to be different. This one's different. So we know the borders of these. This is bordered. This is bordered. This is bordered. These are bordered. These are bordered. Now we don't know what these 4. Okay. So then this can't be 8. It can't be 1 either. This is 2, 3, or 6. This is 8. So this still could be not part of the orange region. So this cannot be 6, 7, or 8. It cannot be 1. It's 2, 3, 4, 5, or 9. This cannot be 1. It's 2, 3, 4, 5, or 9. We need a 1. Where can the 1 be? It can't be here anymore, so it has to be here, right? 1 can't be any of these, and it can only, if one of these two is the connector, the other one opposite it has to be connected. Therefore, this has to be connected and is the 1, because there's no other place for the 1 for the yellow. So this is 6, so that means one of these two is the connection. So therefore, this is blocked, this is blocked. So one of these two is the connection. It's 2, 3, 4, 5, or 9. If this is 9, it would have to be 1, 3, and 5. This cannot be 3 anymore, because if it's 3, we know at least 2 of them are there. So this cannot be 3, because it can't be 1 and it can't be 1 and 2 anymore here. This could be 4, in which case this is 3 and 1. This could be 5, in which case it's 4 and 1 in some order. And it could be 9, of course, in which case it's 1, 3, and 5 specifically, or 3 and 6, or 1 and 2 and it can't be 2 and 7. 4, 5 could be 4, 5 still. Okay, so this is different. One of these two is the same. This cannot be 1 or 2, so this is 3, 4, 5, 6, 7, or 9. This can never be the same as this one, right? Because it can't reach around, and either it's yellow or it's blocked by yellow. So this is the minimum, which means it's 1, 2, 2, and 3. So this is 1, this is 2, this is 2, and this is 3. Therefore, these two must be the same, because this is the minimum. Therefore, this is 8. These two must be the same, which means this must be yellow. Otherwise, it doesn't connect orthogonally. Therefore, this is yellow, which forces this to be 5. This can't be 3 or 5. This can't be 5. This can't be 3 or 5. So we have a 2, 4, 9 triplet here. This only sees 2. This sees all of these. So these two are the same. We're going to make this light, I guess. So this can't be 5 or 8. This can't be 5 or 8. This can't be 1. This is, okay, so this can't be 2. So this is 3, which makes this 6, because we have a 2, 3, 6 triplet. This can't be 6. This can't be 6 or 1 or 2. This can't be, this can't be 6, right? Couldn't be 6 anyways. Whereas the 6 in row 3, it has to be here. This sees this sees this. This, oh wait, hold up. This could still be 6. Never mind. This could still be 6. This is 8. It still could be with either of those. It could be with this one still. These two are separate, so they're different. Okay, so this can't be 2, which makes this the 2. This sees specifically 2. So if it's 4, it would have to be 1, 3, which is not possible. Therefore, this is 9, this is 4. It cannot be 1, 8, or 2, 3, or 2, 7, or 3, 6. So this has to be 4, 5. This can't be 3. This can't be 4. This can't be 8 or 9. So this is 1, 6, or 7. It can't be 1 because of that. Therefore, this has to be a 1 because we have 6, 7 pair in column 4. Row 6. So we have a 4, 5 in row 2. We have a 4, 5 in row 9, or row 6. Both of them have to be 4, 5. Therefore, the rest of columns 8 and 9 cannot contain a 4, 5 because of an X-wing. So this can't be 4, 5. This can't be 5. None of these could be 4, 5. So, well, it couldn't be. So anyways, none of these can be 4, 5. So this is... This can't be 2 anymore. This can't be 2. Okay. This is a separate region. Okay, so all the separate regions are done, I believe, right? So we have this is a separate region from there, so that adds up to 6. These two are a separate region from this, so therefore they add up to 9. These three are a separate region from this, so that adds up to 6. These two are a separate region from this, so therefore it adds up to 3. This is a separate region from this, so it adds up to 3. These two are a separate region from this, so it adds up to 9. These two are a separate region from this, and it adds up to 5. These three are a separate region from this, and it adds up to 7. These four are a separate region from this, and it adds up to 8. These three are a separate region from this, and it adds up to 6. And these four are a separate region from this, and it adds up to 8. Okay, so this can't be 4. These can't be 4 either. This can't be 6 or 8. This can't be 5. So this is 1, 2, 3, 4, 5, 6, 7, 8. And it could go down here as a 9. This cannot be 1, 2, 3, 4, 5, or 8. So it's 6, 7, 9. This cannot be 1, 2, 3, 4, 5. So it's 6, 7, 8, and 9. Therefore, this must be a 3 from Sudoku. This can't be 7 anymore. This can't be 1, 2, 4, 6, 7, 8, 9. Or 7, 6, 7, 9. So this is 3, 5, or 8. This can't be 8. Where's the 2s? One of the 2s is here. This is 4, 5, 7, and 9. This can't be 2 or 3. So this is also 4 or 5. Okay. This is 5, 6, 7, 8, and 9. This can't be 6 and 8, obviously. This could be 3, no 4, 5, 6, 7, 8. And this is 3, 4, 5, 6, 7, 8. Okay. These are obviously... Okay, this can't be an 8 because it's in the same region as this. So this is 3 or 5. This can't be 8. This is 2, 3, or 5, and this could be 2, 3, 5, or 8. So this can't be 1. Okay. This is light. It has to be either with this or this. I mean, technically, well, no, it cannot. If it goes this way, we have 2 1s, and there's not enough cells in this area to make 18, 2 different regions, right? If it goes, so say we went this way to get the 1. But also, where is the 1? We've got 8 1s. The last one has to be here. So that's all 9 1s. One of the 1s goes with this 2. One of the 1s goes with this 2. This 1, therefore, has to go with a 2 here somewhere. So this can't be 1, 3, 4, 5, or 8. So this is 2, 6, 7... 2, 6, 7, and 9. This can't be 2. One of these 2 is 2. Okay. This can be 5, 6, 7, 8, 9. This cannot be 1, 2, 3, 6, or 8. So this is 4, 5, 7, 9. Can't be 4 or 5, though. There's no 5s allowed here. Okay, so this 1 does actually have to go somewhere here. Right? Or maybe not. There's 3 separate regions here. How many digits is there, is the question. Okay, so all the arrows are taken care of, so we don't have to worry about looking at the arrows. Now we're just focusing on regions. We have 2 3s here, actually. So one of the 2s is with 1 3, the other 2 is with the other 3. So say this 2 is with this 3. That seems possible, then. It would have to include this 9. Can this 9 ever be part of this 3? No, right? If it tried to, I guess it could be something like this. But then where does this 3 get a 9? It can't get any from here because it's not part of gray. It can't go... I guess it could go this... I guess it could go this way. Yeah, that's possible. So that is possible. So again, the dark gray could be an orange. Could be the same as orange. We don't know. Hmm. Can this one go with this too? No. Right? Okay, so let's remove these colorings because we already know that there's something there. Can this one go with this too? Wait, no, it could. Right? And then these are the same. Hmm. Hmm. Where? Hmm. So both of these ones take these threes. This one must take one of these threes or one of these threes, right? It cannot contain this one. If it takes this one doesn't have a 3 to go to, or this one doesn't have a 3 to go to. So this one actually has to go this way. We just don't, so it doesn't, we don't know if it goes any more this way. It cannot contain any of these threes again. If it takes one of the threes, there's only one 3 possible for these two ones, and this one cannot be part of this because it has a 1, and same here. It's just too far away too. So this has to be blue. It cannot contain that 3. There is a 2 here. There are one, two, already two twos here. There's a 2 here. So this one of these blue. So if this is a 2, it could go something like that. That's possible, right? This always has to be blue then. Say it wasn't. Where is it going to get the 2, right? This 2 goes with one of the ones. This 2 goes with the other one of the ones. Can't go to the gray. And so therefore those are 2 regions already there. What region can this be part of? It can only be part of blue. So if it goes here, obviously if that's a 2, obviously it goes here. If this is a 2, these both have to be blue. Therefore this is blue. So this is blue either way. So that's blue there. Therefore it cannot contain both of these 2s. Um it can only contain one of them at most. It has to contain, actually, it has to go one of these 2. We don't know which. It cannot be both, though. Um, it does not need to contain both of these, though. Hmm. Mm, can this be the same? No. I mean, 1, 2, 3, 4, 5, 6, 7, 8. The problem is you have 2 separate regions, which, yeah. I don't. I that you would have two separate regions, and that just wouldn't be big enough. I don't think. Right. So say this was the blue, right? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But the problem is one of these two, one of these three has to be green. So yeah, this would not be enough. Therefore, blue and light gray or white are different. Right? Again, just the logic. 1, 2, 3, 4, 5, 6, 7, 8, 9. Assuming white is the same as light blue, this is the minimum you can have. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So technically there would be possibility to have two regions, but this now becomes 1, 2, 3, 4, 5, 6, 7, 8 at most in size, and that's not allowed. Therefore, blue has to be a separate region than light gray or white. Oh, I guess this could be 3, so this actually could be both blues. So this is at least 8. It could be 9. How many cells are this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So can this ever be non-blue? That would be 1, 2, 3, or it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes, that's possible. Huh. Well, this could be part of this one. So that doesn't help much too. So we know one of these two. Can this two belong to this one? Possibly, yeah. Okay, one question. Where is the green 5? 1, 2, 3, 4, 5, 6, 7. It could go 8 and 9, so the 5 could be here, or the 5 is here, or the 5 is here. But this can never be 5 because of that. Ah, we have a 7, 9, 7, 9 pair in row 8. The rest of the row cannot be 7 or 9. Therefore, this has to be 5. This can't be 7 or 9, so this is 4. This can't be 5. This can't be 6. It can't be 3. Therefore, this must be 2, which makes this a 3, which makes this a 5. So then this has to be 2. So this is 8. Very clever. So this can't be 8. This can't be 8. So the 5, yeah, it was a 7, 9 pairing here, right? And this couldn't be... Right. So this can't be 7 or 9 because 1, 2, 3, 4, 5 see it, and 8 and 6 are in the row. This can't be, this has to be 7 or 9 because 6 and 8 are in the row again, and this is 1, 2, 3, and we know all the 4 and 5s are taken care of. So therefore this is 7, 9, 7, 9, which allows us to do that, what we did. So this is 2, this is 8. This can't be 8. This cannot be 4 anymore. This can't be 4 anymore. We know this 2 is not allowed, so this has to go this way to get the 3. So there's 3. This must connect this way, so this is light. This can't be 4, so this must be 5, which makes this 4. So this can't be 4 either. It's 5, 7, 9. This can't be 5 then. This can't be 2. So this is 1, 2, 3, 4, 5, 6, 7. So it must have 2 more, and it must have an 8. And the only 8 possible now is here. So it has to go 8 here. This is no longer valid to be anything but blue, so this has to be the blue, which means this is 7979 pair, which means the rest can't be 7 or 9 in the region. Therefore, this is not 9. This is 6. Therefore, that's 8. This can't be 6. These can't be 6, and it can't be 5. We have a 7, 8, 9 triplet in row 9. Therefore, none of the rest of the non-triplet ones can be 7, 8, or 9. Therefore, this is 3, this is 4, which makes this 7, which makes that 9. So this is 6 and 9, which means this can't be 6 or 9, so this is 7. None of these can be 7. This can't be 5, 8, or 9, or 7, so this is 6, which makes this a 3. 7, 8, or 9. So this is a region. So this 9 belongs to a region, and this 9 must be a separate region. Can this 9 ever reach this 8? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, technically. Interesting. But these two are separate regions. So say this was gray. Well, this could be light gray. That actually does work. Never mind. So this can't be 8. This is 7 and 9. This is 7 and 9. So we have a 7, 9, 7, 9 pair in column 8. This can't be 7 or 9. Therefore, this is 6. This can't be 6. The 5 now has to be one of these two for green. Light gray. So we have a light 8 light gray. One of these is red, or the other region. Therefore, the green must be one of these 3. Okay. This cannot be gray, so we're going to make this the new region. That's red. So this can't be 6. This can't be 5. Orange must go up here. Okay, so then it cannot, if it goes up here and it avoids this, how does that work? I don't even think it does, right? So say it tried to go, it cannot connect to this, because if it tried to do that, it blocks these from having a region. If it tries to go here, it can't go here, because we know this needs at least 2 that are not in its region. So it can't go here because of the same problem. Oh wait, it could go like that. That actually is possible. Huh. Dang it. That is possible as a region. Okay. We're gonna still have to have some logic for this arrow, I guess. So this cannot contain both of these, but... So one of these is 9. If this were 8... If this is 9, it's not part of green. If it's 8, that would have to be 9, and this is not reachable by green. So this can never be green. So it's either red or it's light, but we don't know which. Right, so say we tried to make this green. If this was green, this would have to be, this could not be 9, so it would be 8. So therefore this would be 9, but it doesn't connect. right? 1, 2, 3, 4, 5, 6, 7, 8, 9 would be the only connection, and 9 would have to be there in one of those two cells. So that's not allowed. Okay, so we can remove these. Oops. Because we already have those set. Now we're going to try to figure out what some of these 7, 9 pairs are. So we're going to make that green and this red. Therefore, this must be the green 7, 9, and this must be green 7, 9. What other red ones do we know? I don't know if we know any other red ones. So this could be light gray all the way. Can this ever be red is the question. Yes, because it could be something like this. Oh, the 4s are different ones too. So can this be light? I don't think so, right? If it's light, it can't go here, right? Because that's red. So it would have to go like that to go around. And then you would have an 8 there, which is not allowed in the light. So say you went that way. Obviously, you can't have a 4 there. So if you try to go around and be light, then you would have a 6, 7, which would be part of the 6, 7, which is not allowed. Therefore, this is always red, and therefore this is always light. Since this is light, this must connect. It could connect this way. It'd be a little weird, but it could. And then it could be like, well, but the problem here then is, I guess it could be like this. This is 1, 2, 3, 4, 5, 6, 7, and this would be 8 and 9. That's possible. Can this 1 ever be light? No, because it blocks red. Right? And then the red would not have a 1. So this is always red. One of these two is always red. Light could potentially, cannot go down here. If this is light, so, okay, this can never be light. If this is light, that means it has to connect this way or this way. If it connects this way, that means both 8s are in the light, which is not possible because we already have 8. If it connects this way, that means this would be 7, 9, 7, 9, but we already have a 7 there. Therefore, this is red. Okay. And this has to be the light one. So we have, yeah. Red could go this way. Okay, so say red does go this way. It doesn't have a 6 still. And this can't be red's. Oh, I guess this could be red 6. Okay, never mind. Hold up. Yeah, it could be like that. It could be like this, actually. So that could be red. And then the rest would be gray. So one of these is the red 7, 9, but we don't know which. This is always red. One of these is the red 7, 9, but we don't know which. Can this actually be red? Is the question. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, so this cannot be red. Therefore, it has to be light. Therefore, this is 9. So this is 9, which makes this 6, 8, 6, 8. This could be red. To connect to here, I guess I could connect this way. So one of these has to connect, and therefore is the 6. So it could connect this way to the light, or it could connect potentially that way. But then this would be 6, 7, so that's not allowed. So say it tried connecting this way. That could work, and therefore it would be 6. That's possible. Hmm. We need a 2. This could be 3, 2, right? So 4th. Oh, no. This has to... Right. Can this ever be light? Can it ever be white? This would then be non-red, non-white, so it'd have to be red. So this would be red. Therefore, this would be light, but then the problem is that doesn't work because this blocked. So this one has to be light, which forces this to be red. So therefore, this must be red, which means this is red. So it connects with either one of these two. So we have 1, 2, 3, 4, 5, 6. It connects with 1, 2, okay, we need a 3, so this is light. Which means red, whereas it's 6, it has to be here. Which means this is red too. So this is 7 or 9. So now we have the borders here. So this could be 6, or this could be 6, right? We don't know which. This has to be green now, because it can't be... We have to connect somehow, right? And this is 1, 2, 3, 4, 5, 6, 7, 8. So it has to connect, and it has to connect there. So therefore, this is 6, this is 7, this is 8, this is 6. Therefore, we know the borders here have to be here. Right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, these are green. Therefore, 1, 2, 3, 4, 5, 6, 7, 8, and 9 have to be, this has to be 5, which makes this 8. This can't be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Therefore, this cannot be green. Therefore, it is gray. We know the borders are here then. Okay, so this can't be 8, which means this is 8, so this can't be 8. This has to be the red 7, 9. So it cannot be this one. This can't be 8. So this is 7, 9, 7, 9, which forces this to be 7, 9, 7, 9 pair. This can't be actually 9 either. So this is 7. That forces this to be 9, which means this is a 9, this is a 9, this is a 7, this is a 7. Because of the coloring that we had, we can remove those now. Therefore, this is a 5 because it can't be 7 or 9. This is a 7 because it can't be 5. This has to be a different region than this. Can this ever be orange? Yeah, this can no longer be gray. So this can't be orange, right? If it's orange, it'll block this, and therefore this has to be dark gray. So that wouldn't work. So this can never be orange. This has to be dark gray, which means this is a different region, so therefore it's orange. We don't know about this one. This must connect somehow, and it either connects, it has to connect this way. So this is 6, which means this has to be orange. Therefore, if it tried going this way, okay, wait, this is 1, 2, 3. Okay, this needs a 3. It could be 2, 3, but if that's 2, 3, that blocks orange from orange. So this cannot be dark gray. It has to be orange. Therefore, this is dark gray. One of these two is orange, one is dark gray. This has to be dark gray because it can't be orange. This has to be orange, therefore this is dark gray, which makes this dark gray. We need a 1. It cannot be there, because then that blocks the orange. Therefore, this orange is 1. This has to be dark gray, which forces this to be 4, this to be 5. We actually don't know which one of these two... Oh, this has to be orange, because it has to connect. Therefore, this is dark gray, And we have solved it. And I'm just waiting so that I can put the boundaries and color everything correctly. Therefore, this is a 4, and this is a 5. And that's a solution. Yeah, definitely very hard. But still very cool. I love these chaos construction puzzles because it's a lot of really interesting logic. And this had a ton of interesting logic in it. Anyways, if you made it to the end, I hope you liked this video and you can give it a thumbs up. And I'll see you next time on Frank Puzzles. Take care.